Ratchet and Clank: The Rift Apart on PC is coming very soon, July 26th, from Insomniac Games, although Nixxes is the people porting this to the PC version, and they have a good track record in the past working on games like the Spider-Man games for PC. You can probably hear my kids stomping around upstairs while I film this video, so ignore that. Anyway, I'm very excited to see this, and there's some very interesting stuff in the PC features. For example, I mean, it's nice to see a game that is confirming it is going to support DLSS as well as FSR and Intel XeSS. This should be the standard for AAA games. They're also expanding the ray tracing and things like that, but I think one of the most interesting things is that we have confirmed DirectStorage 1.2 support. This is very interesting for people who understand what this means. Now, why am I quoting this from a forum post at Resetera rather than from the actual original article? So there was a post which has now been removed apparently on Steam, a Steam news post, where the developers talked a bit more about the PC features. So I'm wondering why this was taken down. I don't know if there could be any errors in this, or maybe they just didn't mean to post it yet, that sort of a thing. But I doubt this would be so wildly incorrect that they actually don't support DirectStorage 1.2. Now, why would this be a big deal? Well, so one thing that happens in this game, which is why it was originally launched as a PS5 exclusive, developers were quoted as saying this could only be done with the fast SSD in the PS5. You couldn't do this on older console generations, is it quickly transitions between worlds in this game. And it says, to enable quick loading and instant transition between dimensions, the game needs to be able to load assets quickly. DirectStorage ensures quick loading times, and GPU decompression is used at high graphic settings to stream assets in the background while playing. Traditionally, this decompression is handled by the CPU, but at a certain point, there's an advantage to letting the GPU handle this, as this enables a higher bandwidth for streaming assets from storage to the graphics card. We use this to quickly load high-quality textures and environments with a high level of detail. Okay, so that is extremely interesting. There is no game on PC currently supporting DirectStorage 1.2. The only game right now with any form of direct storage is Forspoken, but that is not 1.2 and does not feature GPU decompression. A lot of recent PC games have been unfortunately quite CPU limited, and possibly that can be related to having to stream in tons of high resolution assets, which again is traditionally on PC done by the CPU. And with DirectStorage 1.2, that can be shifted to the GPU. Now, this will be the first time we see this in action, and I think it's very interesting that they mention that at a certain point, there's an advantage to letting the GPU handle this. So it says that they added adaptive streaming based on live measurement of the available hardware bandwidth. This allows us to tailor the texture streaming strategy for the best possible texture streaming on any configuration. And it says, with DirectStorage, the use of a fast NVMe SSD and GPU decompression, this results in very responsive texture streaming, even at the highest settings. So what it sounds like to me is basically, depending on the graphics settings, right? Because if you have the graphics settings turned down super low, might not be as much needing to stream in all at once, right? But if you're trying to run the really high-res assets, it also sounds like it's going to measure your available hardware bandwidth to decide whether it makes sense to be doing the decompression, the texture streaming and the decompression on the GPU. Because again, I think this might depend on whether you're more GPU limited or CPU limited in the particular scene and settings that's going on here. So I'm just really interested by how this will be implemented in this game. They also talk about some of their ray tracing things that they've added to this game. It will have expanded ray tracing support compared to the console version of the game. And in general, good ultra-wide support, unlocked frame rates, because it has DLSS 3, it'll definitely have NVIDIA Reflex, it'll also have DLAA. Overall, this sounds like all of the stuff that you'd want from a great PC port. Again, we need to see how it actually works in action. and what sort of system requirements will you need to run this thing. A lot of people might be worried that it's going to be extremely demanding, but check this out, guys. At the minimum requirements, this game is not actually asking for much at all. Now, keep in mind that at the minimum requirements, we're talking 720p 30 frames per second at very low graphics settings. So take that for what you will, but it's only asking for a GTX 960 from NVIDIA or an AMD RX 470. A little bit of thoughts on that in a second, because those are not usually equivalent GPUs. And then from the CPU side of things, an Intel Core i3-8100 or Ryzen 3 3100, those are both actually very reasonable CPUs. The i3-8100 is only a 4-core CPU from, 2017, so it's not like super, super old, but it's also, 6 years ago. And was a low-end chip from 6 years ago, 4-core, 4-thread. And the Ryzen 3 3100 was also a 4-core chip, but it did have they call it simultaneous multi-threading. So it could go to 8 threads, and this is a 2020 chip. But again, these were fairly low-end CPUs at the time. So interesting, not asking for too much there on the CPU side of things. Only 8 gigabytes of RAM required here, and it also, I was very interested. I assumed this game would just flat out require an SSD, given that they literally said when the game came out on PS5 that this is only possible due to the fast SSD on the PS5. This just says SSD recommended, but keep in mind, we are talking at 720p 30 frames per second, very low settings. So I think it's actually probably true that the game would not have worked well at PS5 equivalent settings without a fast SSD. And I think that's one of the reasons why they're implementing DirectStorage 1.2 in this game, things like that. I think it actually is very important, and they are still recommending an SSD even at 720p 30 FPS very low settings, but it's not specifically listing SSD required. Although SSD prices have come down so far, guys, if you haven't got an SSD in your system at this point, I understand budgets are what they are, but you might definitely want to think about an SSD upgrade with the prices where they are currently if you haven't yet. It's a very good upgrade for your system. Now let's talk about the 960 for a second, because the 960... okay, so this, first of all, I should talk about what chart I'm using here, and I will link this in my video description. It is very useful, although it's not perfect. This is TechPowerUp.com's relative performance chart, where you can click on any GPU and set it as the baseline 100%, and then based on some of their TechPowerUp review data, they offer a relative performance of other GPUs. So the thing with system requirements list is they pick a couple of GPUs to show you at a certain setting, and then you just hope it's yours, right? Because if it's not, how do you decide where yours falls in between? Well, that's where a list like this is very useful, but also not perfect. First of all, system requirements are often not accurate. But even if they are giving you a rough ballpark figure, relative performance charts like this aren't going to necessarily reflect the exact performance of a specific game. And the older the GPUs get, the less accurate this data can sometimes become. I don't think it's always updated, over time, that kind of a thing. Anyway, according to this chart, though, the GTX 960 versus the RX 470 from AMD is showing the 470 with a 43% relative performance advantage versus the 960. And you can see a bunch of cards in between here. There's even newer cards like the Arc A380 or RX 6400, which are offering similar performance to what we're seeing here. The 1050 Ti is similar in performance to the GTX 960. So if you have cards like that, you're hanging out at this 720p 30 FPS range at very low graphics settings. But again, there's a range of performance in between there that does seem a bit strange to me. But oftentimes, I think system requirements charts are listed based on what the developers actually had in their test systems. And also, usually the 30 FPS number, just means you're not locking 60, but maybe the 960 is getting you 30 FPS, and maybe the 470 is getting you 40 FPS, right? But it's still not 60, so they just lump it in with the 30 FPS category. So you don't want to read too far into all of this. But I will say, as we look at the rest of these charts, there can be some interesting pairings on the GPUs. So let's get a little bit more into these charts. So first of all, let's talk about some themes on some of the, how should I put it? The quicker to talk about stuff. So from RAM, you're gonna jump from 8 gigabytes to 16 gigabytes and then 32 gigabytes. 32 gigabytes, it doesn't jump up to that until we're talking about 4K 60 with maxed out ray tracing. That could also just be that was in their test system. But at the absolute max, it does say maybe go up to 32, but for the most part, 1440p 60, high settings or even some ray tracing enabled 16 gigabytes of RAM. Nothing seems pretty crazy there. And again, as soon as you get past the absolute bare minimum, it is saying that an SSD is where you'll want to be. Okay, it's also mentioning when you look at the ray tracing requirements that it is recommending using upscaling like DLSS, although remember I confirmed that it is saying support for FSR2 and XeSS technologies if you're using, not just using ray tracing, but it says using ray tracing reflections in combination with ray traced shadows and or ray traced ambient occlusion. So it's looking like the ray traced shadows and ambient occlusion might not be super incredibly demanding, but if you also enable the reflections, it's probably going to tank your frame rate to the point that you'd want to enable some upscaling on these. Anyway, so if we get up to the recommended specs, so 1080p 60 frames per second at medium graphic settings, it's saying that an RTX 2060 or an RX 5700 should get the job done. It's also bumping up the CPUs. So remember, the CPUs on 720p low 30 FPS were these 4-core CPUs. You're staying within the same hardware generation on the CPUs when you go up to 1080p 60 FPS, but you're jumping up to some more cores. So if we take a look at these, we're jumping to the i5-8400, which is a 6-core, 6-thread CPU. And again, coming from 2017. And then if we look at the Ryzen 5 3600, this is a 6-core CPU as well, but it did have multi-threading up to 12 threads and was a 2019 chip. So again, not the latest and the greatest, but certainly is asking for more cores going on there to even out your 60 FPS experience from what they're doing. Again, also it can just sometimes be based on what's in their test system, and not that they necessarily tested every CPU, above or below this to see exactly where you'd fall. Anyway, so on the GPU side of things, we're now jumping up to an RTX 2060 or an RX 5700. This is a very large jump, but from the 960 and the 470, but that makes sense because we're not only going up from very low settings to medium settings, which is going to ask for more GPU performance, but we're also going up from 720p resolution to 1080p resolution, which is going to ask for more GPU headroom. And we're going from 30 FPS to 60 FPS, which is again going to ask for more GPU headroom. So it should make sense to see us asking for more than double the performance, and we do. If we go from the 960, set that as the baseline, and now again, you might find your GPU somewhere in between here. So be looking through this chart. Do you see your GPU relative to the 960, right? So where are you falling, right? Like the GTX 1060, 72% better than the 960, but we're still going to be below the recommended, right? So you'd fall in between the very low 720p 30, the 1080p 60, all of that. So we're scrolling up here, seeing some popular GPUs like the 1650 Super, the 1660, the GTX 1070, RTX 3050, and here we see the RTX 2060. Again, it's about 2.7 times the performance of the 960 according to this relative performance chart. Again, this thing's not perfect, but that does make sense. We're going from 30 FPS to 60 FPS, which would require doubling of performance, and we're increasing resolution and graphic settings. So this does make sense to me. And then if I now set the RTX 2060 as the baseline, we can see if the other recommendations make sense next to it. So they claimed an RX 5700, and that does seem to be, well, normally maybe a little bit better in the same general ballpark, right? They're not claiming these are going to be exactly equivalent. They're just giving you GPUs that are going to get you about the same 60 FPS, 1080p kind of experience at medium settings. So where does your GPU fall relative to this? Again, you might have something like a GTX 1080, 1070 Ti, RTX 3050, and now you're a little bit below, but I'd say within the same kind of general ballpark. GTX 1070, 1660 Ti, again, a bit weaker here. You might have something a bit stronger, like a RX 6600, which, by the way, you can get for about $180 right now. The prices come way down on the RX 6600s, so that would be a decent way to get in the door here if you're looking for something to play at this, 1080p 60 medium kind of settings. RTX 2060 Super, cards like that, okay? Now, let's look at what it takes to jump up to 1440p 60 or 4K 30 at high settings. It looks like we're now going to jump up to a newer generation of CPU. Now, whether that's actually needed, I don't know. The CPU recommendations on system requirements videos tend to be a little spotty, because again, it could just be that that's what's in their test systems, right? So when they move up to their higher next level test system, they increase both the CPU and the GPU. Who knows it? Because some graphic settings do affect the CPU, but many don't. And resolution does not usually affect the CPU. So moving up to 1440p should not, if you could get 60 FPS at 1080p, you should still be able to get 60 FPS at 1440p at the same settings. If moving from medium to high increases the CPU demand, that really depends on what graphic settings are involved. But it is going up to a newer generation of Ryzen and Intel 6-core CPU. If you want to look at the details of those, we're jumping up to the 11400, which is 6-core 12-thread CPU from 2021 from Intel, and the Ryzen 5 5600, which is a 6-core 12-thread CPU from 2022. And that's what we're seeing on the CPU side of things. From the GPU side of things, we're jumping from the 2060 to the 3060 Ti, and from the 5700 to a 6800. Now, 3060 Ti versus 6800 feels weird to me here. Let's go to the relative performance chart, and I think you'll see why. So let's keep the 2060 as the baseline. So again, you may find your GPU somewhere in here as we go, so let's scroll down. So going from the 2060, and we're passing GPUs like the 6600 XT, the A770, the RX 7600, the RTX 4060, which is slower than a 3060 Ti, believe it or not. So we're jumping about 50% performance from the 2060 to the 3060 Ti, although depending on the game, that could be an even larger gap. But if I now set the 3060 Ti as the baseline, this is what feels weird. The 6800 from AMD is usually about 30% faster. And it also has 16 gigabytes of VRAM instead of 8. So in situations where the 3060 Ti spills over 8 gigabytes of VRAM, which we have no idea if that'll be happening in this game until we test it, then the 6800 would have an even larger lead. So again, a 30% performance difference right there feels weird to me. It could just be what's in their test systems. Again, it would feel weird if it was relying on DLSS to get that performance jump, since they only mentioned DLSS when talking about the most advanced ray tracing settings. Although maybe it's possible they are talking about using some upscaling. Some games, graphics presets actually do enable upscaling on their own, and maybe the game developers are just talking about that. But again, the game does have FSR2 as well as DLSS, so it seems like if it was enabling it on one, it would enable the equivalent, equivalent technology on the other one. I mean, I would agree that DLSS would usually give you better image quality in most games. But anyway, so that feels weird. So I'm just going to point that out, but until we actually test the game, I don't know what to make of it. There are some games that just prefer one GPU hardware over the other. There are games where NVIDIA outperforms AMD compared to their average, and there's games where AMD outperforms. Maybe this is a game where the NVIDIA hardware just kind of outperforms its average. That does happen sometimes. Now, if we jump into enabling some ray tracing, here's where I think it makes more sense to have like a 3070 paired with a 6800 XT. Which would feel weird normally, but if we're talking ray tracing, that makes a bit more sense. So if we go from the 3060 Ti up to the 3070, you're getting a bit more performance, and that's should be enabling your ray tracing settings, although not at the highest level. And then if we set this as the baseline, the 68, again, you might find your GPU somewhere in between here. The 6800 XT is usually 25%-ish faster than the 3070. Again, game by game, that can vary. But with ray tracing enabled, depending on the ray tracing workload, oftentimes the 6800 XT will fall back to a tie with the 3070 or even lose to the 3070 depending on how heavy the ray tracing burden is. Although there are times where the 6800 XT's 16 gigabytes of VRAM actually keeps it well ahead of the 3070 because ray tracing does usually use more VRAM. And then that can cause some issues for the 8 gigabyte cards. But again, maybe this is enabling upscaling because at ray tracing high, it is talking about that's where we get this use of DLSS could be factored in there. But again, I would imagine that would also be factoring FSR2. On the CPU side of things, it's once again jumping up a little bit more, although 5600 to 5600X, this is where I feel like it's just what happens to be in their test system. Because a 5600X and a 5600 are within single-digit percentage differences of each other in terms of performance. It's a very small clock speed difference on basically exactly the same hardware. Going from the 11400 to the 11600K, the 11600K is a 6-core 12-thread chip because it has the K, it has overclocking ability. This is from 2021. There's that. And then I will say, though, that ray tracing actually does often increase the CPU burden. So it actually does make sense for me if they do want to increase the CPU requirements going from no ray tracing to ray tracing enabled. And then at the ultimate ray tracing level, for 4K 60 FPS, they're jumping up to an RTX 4080 or Radeon 7900 XTX. And they're also increasing the CPU demands, and like I said, that could just be that that's their high-end test systems, but it could also mean that enabling the highest levels of ray tracing does actually increase the CPU demand. Notably, we're getting a significant core count bump. Going up to the 5900X from the 5600, you're jumping from 6-core 12-thread to 12-core 24-thread. Again, sorry for the noise from my kids upstairs. And 11600K to the 12700K, you're getting a bunch of efficiency cores added in there, as well as more performance cores. The 12700K is a 12-core, 20-thread processor because 8 of the cores are actual performance gaming cores, and then you get a bunch of some efficiency cores added in there as well. This is a very new chip from 2021. And then the Ryzen 9 5900X, again, is a 12-core, 24-thread CPU from AMD. So again, it can be reasonable to actually expect heavy ray tracing to increase the CPU burden, and it would be nice actually if this game is taking advantage of more cores and able to do that, whereas some games just get very single-thread bottlenecked when they have the when ray tracing gets enabled. We've seen that in a lot of recent games, especially in Unreal Engine, but I didn't actually check on it. I don't think this is an Unreal Engine game. Anyway, on the GPU side of thing, again, jumping up to the 4080 or 7900 XTX for 4K 60 FPS. So basically, you need some of the best GPUs on the market if you're going to absolutely max out the game at 4K 60, which I don't think is crazy to expect or ask. Maxing out the latest titles at 4K 60 is a lot, especially with ray tracing. From the 3070 to a 4080 is an almost doubling of graphics performance if you want some kind of a scaling there. Also, the 4080 goes up to 16 gigabytes of VRAM, which is quite a bit more. And again, the 7900 XTX has similar performance, although in ray tracing, especially heavy ray tracing, the 7900 XTX can fall behind. I've done some recent comparisons if you're interested. All right, guys, this video was actually a lot longer than I expected. I am very interested in testing this game out when it launches, so let me know if you're interested in seeing that in the comments section. And again, I'm glad to see Nixus on top of the PC port. That is promising to me, and DirectStorage 1.2, the first implementation we see of that. I'm very interested to see if that will relieve some of the CPU bottlenecks that we've seen in recent games, although I'm curious if you'll be able to turn any of that on or off. Or they said it adapts on its own. I'm curious what sort of tests you could devise to look at how much, if any, the GPU decompression is helping ease CPU burdens, that kind of a thing. Anyway, game's coming out on July 26th. I know the PlayStation version had very good reviews and all that. I haven't actually played it myself yet, so looking forward to trying it out on PC. I hope all of you have an excellent day.